So we were discussing about the knowledge representation, the second unit of artificial intelligence, and we were talking about the frame-based systems. We were talking about the frames. In frames, we had talked about that the frames are the data structures that are used in the artificial intelligence to represent the stereotypical situations or the scenarios here. Or simply, we are using here the object-oriented techniques, which is the encapsulation. So what we were saying in the frames that they encapsulate the information about the objects, events, and their relationships within a particular context. And we had also talked about that the each frames consist of a set of attributes and their values, forming a template for understanding the specific situations. In the frames, we have talked about that the components in a frame, we have talked about the slots, right? The facts, the procedures, the default values, the procedures. And we have taken the example of that also. So we have discussed about the semantic nets also. We have discussed about the inheritance in a frames. We have talked about this procedure. Till this procedure we have talked about. Then when we are talking about the inheritance, right? We have talked about this example. We have taken the example to complete the frame of a book in a library management system. In the last lecture, we have talked about this example, right? And then we were talking about the inheritance in a frame. We had also discussed about the key concepts of a frame inheritance, or simply what is the inheritance and what concept of inheritance we are using. We had used this, and then we have seen about how the frame inheritance work. We had also seen this by defining the parent frame, then child frame, then overriding the parent frame features and the functions, use the inherited attributes. In that also we have taken the example of a library management system where we have talked about the book and the magazine are the inherited classes of a parent class library item. This example we have seen is in the last lecture. Then we have seen, and now we were talking about the applications of a frames in a air, and after that we will talk about what are the frame-based systems. And the topics are left is the forward chaining and the backward chaining further in a unit 2. So first we will talk about the applications. We have discussed the application of a natural language processing, expert system, robotics, and the cognitive modeling. In the natural language processing, frames are used to understand the context of words in the sentence, right? For example, a booking frame might be used to interpret the request for the reservations, right? How many requests are the what request for the reservation, extracting the relevant information for the reservation, such as the date of a reservation, the time, and the number of people that will be traveled, right? So that comes under the natural language processing. We are taking an example here. Then various expert systems use frames to represent the knowledge about specific domain here. When we are talking about expert system, definitely we are talking about a particular domain-based system. For example, a medical diagnosis system might employ frames to represent the various diseases, symptoms, and the treatment options. Then the robotics, another uh, application of a frames in the artificial intelligence is the robotics. How frames helps in robots. Frames helps robots to make sense of their environment. They can sense their environment by providing the structured information about the objects and their properties. They can identify the objects and their properties by defining the attributes. This allows robots to perform the tasks such as the object recognition and the manipulation according to their properties. Then we are talking about the cognitive model. So what do you understand by the cognitive modeling? कोई बता सकता है? So what is the cognitive modeling approach? when we are talking about in artificial intelligence, that is the practice of designing a artificial intelligence system that mimic the human through the processes, attempting to replicate how humans solve the problems. Simply here we are talking about the machine learning to make the decisions according to the as the human do and learn by stimulating underlying the cognitive mechanisms like the memory, reasoning, and perception, rather than just achieving the optimal results without considering the human-like subjects involved. So here we are talking about in the cognitive modeling, basically we are talking about brains are used in a cognitive modeling to simulate human thought and the process. Because in a cognitive modeling, we are talking about the focus on a human cognition, right? And where we are using this, it's a combination of all above two application that we have talked about right now, the NLP expert system and the robotics. Or simply we are using in the areas like the net, where we are using the cognitive modeling in the NLP, in the robotics and the expert system, where there is a needed of a human understanding a human context and reasoning, right? So here, when we are talking about a cognitive model, what techniques we are using, and in which we are talking about the cognitive modeling, we are talking about a knowledge representation technique, right? So we are using frames in this, and for example, when we are talking about the cognitive models, we can implement various methods, including neural networks, hybrid approaches, right? From the psychological theories of a different psychological theories. So here we are using the frames for cognitive modeling to simulate the human thought process. By representing the knowledge in frames, researchers can create the models that mimic the human reasoning and the decision making. So this is the most important application under the frame, right? As we will see the frame-based expert system example also, we will see that also in our further notes. So what are the advantages of a frame? Definitely a organized knowledge. Somewhere the objects, its attributes, its procedures, slots, facts, default values, procedure, that are the four components of a frame. We are defining the knowledge in an organized manner. So, or representing a knowledge in an organized manner. So frames help in structural information in a way that mirrors real world scenarios, making it easier for the AI systems to understand and the process. Simply the data structure it use, the structuring information it use that is very organized. Another, because here we are talking about the object-oriented approach, here we are talking about the modular approach. So somewhere the flexibility in the reusability is the another advantage. Frames can be easily modified or extended to incorporate new information or adapt to the changing context. How? Again, as we talk about the frames, it is basically the modular approach or the object-oriented approach. So it is for extending a particular module is easy. Now, reusability, once defined, frames can be reused across different applications also because of a particular object here we are using. We are combining the subsystems to form a system. So here we are talking about the various functions or the modules. So once defined frames can be reused or a particular module can be reused across the different applications or the scenarios and promoting consistency and the efficiency. So these are the three main advantages of using a frame. And now what is the complexity, context sensitivity and the scalability? These are the limitations or the challenges under a frame-based systems. So what comes under the challenges and the limitations? Challenges are as the number of frames and their relationships increase. Managing and maintaining the frames can become complex. We have seen this. Context sensitivity. Frames may struggle to adapt to highly dynamic and ambiguous situations where predefined structures may not fit. right? Highly dynamic or the real world scenarios or the ambiguous situation where the number of data for a particular data is present or the meanings are more than one. In that case, predefined structures may not fit. When we are talking about the scalability, for the large system, the sheer volume of a frames and their interactions can pose the challenge in terms of a performance and the resource management as the system will get more complex. So from the very beginning, we are talking about the knowledge representations, right? Semantic networks, we have talked about the knowledge representation from the very beginning. In the unit, in this unit, we have talked about from the beginning. I am talking about now again. We had talked about the knowledge representation. What is the knowledge representation, right? Then we had talked about the various methods under the first logic, order logic or the predicate logic. Then we had talked about the semantic frames and the ontologies. But in our unit, we are talking about the semantic networks, which we have further divided into a partition networks, and then we have talked about the frames. And when we had talked about the structure representation, somewhere we had talked about the ontologies also. So what was the ontologies? It defined the concepts, hierarchies, and the relationship within a domain using a standard like web ontology language, or simply for a particular domain. Here we are talking about the ontologies for semantic search engines and healthcare diagnostics by standardizing the terminology. Now, what is the difference between all these structural representation or the knowledge representations here? We need to discuss. So first we will discuss the difference between the semantic web, semantic networks, and the frame. We have talked about all these things of our knowledge representation. We have talked about the first order logic, right? Then the semantic networks also. In semantic networks, so we have discussed all the components, the working examples also. We have talked, seen this example also. And now, what is the difference between, because we have completely understand about the frame-based representation and the semantic network-based representation. So what is the difference between the both? Semantic networks and the frames are both used for the knowledge representation, but they are different in their structure and the approach, and both are the structural representations. So when we are talking about the difference between the semantic network and the frames, first difference is the representation, which is the graphical representation with nodes and the edges in the semantic networks. And in a frame, they are data structure with the slots and their values, which can be the default values, right? And if we talk about the components in the semantic networks, this is the basically a relationship between the concepts. So the components, the main components in the semantic networks are the nodes that are the different concepts, and the edges that are the relationship between the concepts. And when we are talking about the frames, we are talking about the slots, the attributes, and their values or the pillars or the default values, and all the procedures also that are the components of a frame. In form of a structure, semantic networks provide a hierarchical or the associative network of a concepts. How the different concepts are associated with each other. The relationship between in the semantic networks is based on a concepts. And in terms of a frame, the structure is a particular proper structure, often hierarchical, but focused on a specific entities or a specific scenario, or a specific entities or a scenario here. Now, what is the purpose? Purpose in the semantic network is to represent the relationship or the association between the concepts often used for reasoning, right? We have talked about the reasoning also, what is the reasoning and how you define a reasoning in the AI. And in a frame, we represent the stereotypical knowledge about the objects of the situation, right? Now, in uses, we used semantic network in a knowledge representation, reasoning, and the instances. And for the frame, we use to model a structured knowledge like the structured knowledge like the object events of the symbol. Flexibility, semantic networks more flexible in representing the complex relationships, and they are more rigid with predefined slots and the somewhere with the predefined slots or the default values. Example here, we are talking about in a semantic network that dog is a mammal and mammal is an animal relationship. And in the frame kind of a network, we are talking about the frame of a car might have a slot for make, model, and the color. So we are providing here the description. Then in handling of a default value, because another important component of a frame, we had talked about the default values. So in the semantic network, we didn't talk about the default values. So another difference is it does not inherently handle the default values. But in a frame, because we are talking about the inheritance, and so here we are talking about the overriding concept, the overriding of a function from the parent class, and can include the default values for the slots which can be overridden. For the reasoning capability, where we are expecting something from a machine, in that case we are saying that it supports the inferencing through the relationships. Example, the inheritance. And we here in a frame we are talking about typically involve the simple procedure attachments for the reasoning. Modification, as in the frame we had talked about in the advantages, also about the easier to modify, or the reusability, or the extensibility, right? So in a semantic network, it can be more complex to modify due to interconnected relationships, because in here we are talking about the relationships between the concepts and the nodes are interconnected with each other. So if we will modify something, it will be complex because of a modifying will be complex in terms of a semantic network. But in a frames, we are using a modular approach, so it is easy to modify a specific frames by simply adjusting its slots and the value. So this is the difference between a frame and the semantic network. Then we had talked about completely semantic network. We had talked about the parallel inference also, equations, the parallel implementations also. We have talked about the completely about the frames. Now, what is the difference between frames and the ontologies? Three structural representations. In depth, we are talking about the difference between all. First, we have talked about the difference between the semantic networks and the frames. Now, we are talking about the difference between the frames and the ontologies. So, can any one of you explain about what is an ontology? कोई समझा सकता है? Ontology हमने डिस्कस किया है. So what is the ontology? Is basically to organizing our knowledge to understand and reason about the particular domain here, right? So here, in terms of a definition, we are talking about the frames. The frames are the data structure representing the specific situation, or we are seeing the specific instance according to the object. We are talking here about the object-oriented concepts about the class of the object, right? And in the ontologies, we are talking about the formal representation of knowledge domain here. So what it includes? It will include the structured data. When we are talking about the ontologies, it will include the structured data. It will include the understanding the concepts. Then it will create the various AI models, and it includes the decision making. Or simply when we are talking about the ontologies in a form of application, here we are simply using the e-commerce, the energy management, or the bioinformatics according to a particular applications here. So in terms of a structure of the components, if we talk about frames, have a components like the slots, facts, the default values, right? The procedures, we have talked about the four components under the frame, the slots, facts, default values, and the procedure. And in terms of ontologies, the components of ontologies we are talking about classes, their subclasses, their properties, and the instances here. So here, flexibility adaptable to specific contexts and scenarios. Flexibility is there, and the ontology is formal and standardized, designed for the consistency across the domain. So what is the uses of a frame? We have talked about in the application, the entity, the expert system, the cognitive modeling. What is the use of ontologies in the semantic webs, in the knowledge management, and the data integration, right? Because of a domain knowledge representation here. So data integration is the main uses of a ontologies here. In context, the context specific can vary in a structure, and in the context, the ontologies are the domain wide, provides a shared understanding. Formalism, when we are talking about the things, they are less formal as compared to ontologies. So less formal, more flexible. And when we are talking about the ontology, they are the formal representation of the highly formal use of specific languages, or the, as we have talked about, the what specific languages we are talking about here. So if we talk about the components of ontologies, we are talking about the various classes, the subclasses, or the individuals for a particular instance of objects and the concepts or the classes. Classes, you must know what are the classes. It's a set of a collection of a various objects or the attributes, properties that a particular object may possess, then the relations in which the concepts are related to one another. So different languages or the different ontology languages are present here. Like here we are talking about the web ontology language. So when we are talking about the complex representation, so ontologies are very essential for the organizing and interpreting the complex information by defining a clear relationship between the concepts. So you can say that we are somewhere using the ontologies in the applications where the complexity is needed. So frames and ontologies both are the valuable tools for the knowledge representation in AI, but serve in a different purpose. Frames are useful for representing the specific context-dependent scenarios and are often used in applications requiring the flexibility and the adaptation. So where the flexibility and the adaptation is a requirement to use the frames. And the ontologies, on the other hand, provide a formal and the standardized way to represent the knowledge across the entire domain, so facilitating interoperability and the consistency. So here the focus is the interoperability and the consistency, and understanding these differences help in choosing the appropriate tool for the specific task or the application. Simple. So frames are the fundamental tool in AI for representing and managing the knowledge about the world by providing a structured approach to what main uh, characteristics here we are talking about. By providing a structural approach, first characteristics to encapsulate the information. The second characteristics here is the encapsulated information. Frame enhance the ability of our AI system to reason, input, and make decisions. Another characteristics, despite their challenges, frame remain crucial component in various AI applications, from the natural language processing to the robotics, right? As it contribute in AI to evolve, the role of a frame in facilitating the intelligence system will likely become even more significant.